In this video, we solve problem 9 of unit 13. In this problem, we have 3 resistors connected among them and with a real battery. So I'm going to call R1 to this the resistance of the first resistor, R2 to the one of the second, and R3 is going to be the resistance of the third resistor. And this part here is the electromotive force of the battery, and this R, small r, is going to be the resistance of the battery because it's a real battery. So we have the different resistances here in the plot, and they also tell us that there is an electric current flowing across the first resistor, which is 6 amperes. So the first question they ask is, what is the potential drop in the third resistor, and what is the potential difference across the battery terminals? And this is, so they're asking in A, they're asking what is V3 and what is VAB, okay, the potential drop. They're asking these two. So the first thing would be to discuss that this point here, all these points here are all joined by the same wire, so they have all the same potential, electric potential. On the other hand, I'm going to signal here that all these points here here are all connected by wires, so they all have the same potential. And last, we have these points here that are connected with the same with the wire, so they have the same potential. So the first thing is to realize that the potential drop across the third resistor is equal to the potential difference between in the battery, okay, across the battery terminals, and that this is equal to the addition of the potential loss across the first resistor plus the potential loss across the second resistor, because these two are connected in series, and this is the same point as this one. It has the same potential, and here it has the same potential as here. Okay, so now we just have to apply Ohm's law to know what is the potential drop across the first resistor, which is going to be the current across the first resistor times the resistance of this first resistor. So this is 6 ampere times 1 ohm, which gives you 6 volts. For the second one, we're going to have that this is the electric current across it times its resistance. So as both R1 and R2 are connected in series, the electric current crossing one is equal to the electric current crossing the other. So this is again 6 amperes, and this is times 3 ohms. So this is 18 volts. So from here we can see that V3, which is equal to VAB, is equal to 24 volts. In B, they're asking what is the current in, what is I3, which is the electric current across the third resistor. And this is easy also applying Ohm's law, because this is going to be equal to the potential drop across this resistor, which we already know, divided by the resistance of this resistor. So this is going to be the 24 volts divided by 6 ohms, which gives you 4 ampere. Then they're also asking what is the electromotive force if the internal resistance of the battery is 0.2 ohms. So to solve this, so we have in C that the internal resistance is 0.2 ohms, and they're asking what is the electromotive force. And this is easy if you realize that the potential difference across the battery terminals, VAB, has to be equal to the electromotive force minus the intensity times the resistance, the internal resistance. So from here we can say that the electromotive force is equal to the potential difference across battery terminals plus the electric current that flows through the battery times the internal resistance. So here we don't know yet what is the the electric current. But if we go back to the drawing, to the drawing of the circuit, if we go back here, we can see that the current flow in this battery, which we call directly I, is going in this junction is divided by the current that goes through R2 and R1 plus the current that goes through R3. So the whole current, that's the whole electric current, is going to be equal to the one that goes through the first and the second resistors, which I call just I1, plus the one that goes through the third one. Okay, so joining everything together, we know that this is 10 ampere. So this ideal electromotive is going to be equal to 26 volts. Then we have a last part in this problem, which is asking about the power loss in the third resistor. So this is easy if we remember that the power loss across the third resistor is going to be equal to the current across it times the resistance. Okay, or it's as we have so many data, we also can calculate it this way. In any way, this should be equal to 108 watts.